So here's a case of factoring a binomial with two terms, and this happens to be a difference of squares. That's one of the cases of a binomial that you can factor. So a difference, of course, means minus. This is minus. And difference of squares means that the two terms are perfect squares, and they are. So let's see why. 9x to the fourth is a perfect square because it is the same thing as something squared. In fact, it's the square of 3x squared. 25 over 81 is a perfect square because you can square 5/9 to get it. So perfect squares are the result of squaring something. Okay? So how does it factor? These are very easy to factor. It's a binomial times a binomial. To get 9x to the fourth, you need 3x squared and 3x squared. Notice this is a binomial, meaning there's no middle term like there is in a trinomial. Okay, so the key to factoring a difference of squares is making sure that the middle term doesn't show up when you FOIL. Alright, 25 over 81, you can multiply 5/9 by 5/9 to get that. These are the two things we found over here. But I need negative 25 over 81, so this one's going to be plus and this one's going to be minus. A positive times a negative is a negative. Now think about this if you were to FOIL it. Okay? 3x squared times 3x squared gives us the 9x to the fourth. That's good. The positive 5/9 times the negative 5/9 gives us the negative 25 over 81. That's good. But then we have to do the outside, multiply those, and then we also have to do the inside and multiply those. Now look at this. The yellows, when they multiply, is a negative, and the purples, when they multiply, are positive. And they're the same thing, so they cancel out when you add them together. That's why you get no middle term when you FOIL. So a difference of squares is always going to be a plus and a minus to cancel out the middle term. So we have factored this binomial, which is a difference of squares.